So here is our reaction flask, the 250 ml round bottom flask, in which I have added 8 ml of water, 0.1 mole of butanol and 0.12 moles of sodium bromide. There is a reason why we are adding the exact amounts. And to this we are going to add 13 milliliters of concentrated sulfuric acid. You have to be very careful because this is concentrated sulfuric acid. It's not dilute or it's not mildly concentrated either. As we add the sulfuric acid to this, it's going to generate a lot of heat as the acid dissolves and becomes more dilute in the 8 ml of water. It's a very exothermic reaction. The process is very exothermic, and because the heat generated could cause fumes to rise and could potentially cause the container to become very hot and you to drop it, we are going to actually do this step inside a cold water bath. The cold water bath is prepared by adding some chunks of ice to regular water, and we are going to lower our round bottom flask in it while we slowly add the acid to it using a stemless funnel. And as we add the acid, we are going to constantly stir our round bottom flask. Now for this step, as I was saying, that there is a reason why all the quantities of the acid, the salt, sodium bromide, our substrate, butanol are given in the exact amounts, and you have to come up with which is the limiting reactant. Is it going to be butanol, that's the limiting reactant? Is it sodium bromide or is it sulfuric acid? Find out the number of moles of each, and using that data find out who is the limiting reactant. Once you know who the limiting reactant is for this step, you will know what exactly is going to be the amount of bromobutane that you make, which will allow you to find out the % yield in the last step.